Thank you, Alejandro. So today I'll be talking about our work in South Florida. So South Florida is home to the largest coral reef system in the continental US. It's home to 6,000 marine species and several maritime heritage sites. The Florida Reef Tract spans a narrow band that begins north of Miami and continues south and west along the Florida Keys, which are a chain of small islands. Key West in the lower Florida Keys is about 145 kilometers north of Cuba. Approximately 6.7 million people live in this region alone, where coral reefs support $4.5 billion in annual tourism and recreation-related spending. The marine environment in this region is managed by several agencies with overlapping responsibilities from the county level to the state level to the national level. So you may have heard about Biscayne National Park or the Everglades National Park or the Dry Tortugas National Park, but the largest administratively bounded region in this area is really the Florida Keys National Marine Sanctuary. Next slide. So I work for the Florida Fish and Wildlife Conservation Commission, or FWC, and we are broadly tasked with managing fish and wildlife for their long-term well-being and for the well-being of people. This inherently requires an ecosystem-based management approach, and we maintain an extensive monitoring and modeling programs to fulfill this mission. Next slide. So when the Florida Keys National Marine Sanctuary recognized the need to rezone or redraw their existing managed areas, we were a key stakeholder. So you can see in this map, the existing boundaries in the sanctuary are in this gray dotted line. And within these boundaries are smaller protected areas that manage exploitation or other specific activities identified in red. And you can see that they're very small. And by the sanctuary's own admission, no longer sufficient for protecting marine resources. Next slide. So different groups within different areas of FWC support the sanctuary in different ways. In my section, the Center for Spatial Analysis, we provided support for the rezoning process as well as the reporting process. Meaning, on one hand, we provided people with GIS support where rooms full of stakeholders need help drawing maps. I mean, that's pretty straightforward. But I was really interested in the reporting side. Ultimately, FWC and the sanctuary need to know if these zones are effective, regardless of whatever design they ultimately implement. They need to know the status of biological resources, but this quickly becomes a challenge for handling data volume, particularly from an ecosystem perspective. FWC is just one agency, but multiple institutions and groups in the region collect various types of data on different ecosystem components. So to address this reporting need, we formed partnerships, we promoted data standards and visualization, and created ecosystem models. And I'll work through each one of these. So next slide. First, we partnered with the Marine Biodiversity Observation Network, or MBON, to help organize and make sense of the data. So MBON is a network of scientists, managers, and users across academic, private, and government institutions that are heavily invested in bringing together biological data to support ecosystem-based management. You may have heard of MBON because it's a thematic node within the group on Earth observations, as well as work with the IOC that Alejandro mentioned. And the US-based MBON is supported by the NOAA's IUS office. Next slide. So working within MBON allowed us to visualize complex data sets in intuitive and interactive ways that we probably otherwise could not have done on our own. For example, in this data portal on the right, we combined in situ fish and coral monitoring data with sea surface temperature data across space and time. So these sliders on the bottom allow you to seamlessly look at different time periods and spatial scales without having to constantly turn layers on and off. And in this example, we knew that 2010 was an unusually cold year that led to high coral and fish mortality. And we could have just shown a static time series graph of temperature and coral cover, but there was a little more to this story. Here, we used sea surface temperature to infer the position of the loop current. In this case, the loop current in dark red does not extend as far north into shallow water as it normally does, which resulted in a colder year. In warmer years, it extends further north. So with these types of portals, we could go beyond simple graphs to make inferences about regional environmental factors affecting the system that are well beyond the spatial extent of the sanctuary and the spatial scale of our in situ sampling. Next slide. Second, we built an ecosystem model because we wanted to contrast management zoning strategies, specifically in terms of exploitation, but we also wanted the capability to predict potential indirect effects of zoning on groups of species that we may not otherwise anticipate. We used the EcoPath with EcoSim and EcoSpace model for this goal. It's one of the most common ecosystem models in the world. You can see on this map in the top right that each point is an EcoPath model someone created. In this approach, you're making sense of the data by aggregating species into trophic groups and building a food web from information on diet, consumption, production, biomass, and catch. New capabilities allow you to predict food web dynamics in a spatially and temporally dynamic way by integrating GIS and the base ecosystem dynamics. In our case, we predicted the distribution of biomass across trophic groups in monthly time steps over 20 years in response to satellite-derived environmental factors, as well as different management zoning strategies. Often, in just making this type of model, you come to understand where your data gaps are in terms of understanding the system, and this can drive your research priorities. So in the panel on the bottom right, we came to understand that the model was sensitive to movement and fishing effort parameters, so that when the sanctuary wants to examine potential indirect trophic effects based on their chosen plan, we know that they'll need a good handle on movement and the distribution of fishing effort before they can even do that. Next slide. So moving forward, data visualizations and ecosystem models are just two technical solutions to informing MSP from an ecosystem management perspective. There are many possible portals, models, ways of combining the data, but it's important to consider that these frameworks need to be fluid to adapt to changing priorities, changing threats, etc. By far, the most intensive part for us of implementing these solutions is combining different types of data. So for us, sustaining an ecosystem perspective in MSP really requires two things beyond the technical aspects. One, we need to maintain feedback from our network. We really go out of our way to follow up with people, set aside funds to meet people face to face, if possible anymore, and host workshops that really do deep dives into the data and the solutions to make sure we are meeting those needs. And last, we promote best practices. When working with other people's data, we've been largely successful because we've taken great care to understand the metadata and taken deliberate steps to build trust from our data contributors. Okay. Yeah, so this was the last slide anyway. Just some resources. If you want to contact me directly or explore MBON or explore the keys rezoning process. That's it.